Welcome to this video on 2D material groups in TonCut. Today, we'll explore the key features and settings to help you optimize your materials efficiently. As you may already know, material groups play a crucial role in linking pieces and stock within the system. Pieces belonging to a specific material group can only be assigned to stock items of the same material group, no exceptions. So, all the pieces will be placed either on this stock item or that one, but never on a different group stock. However, material groups offer much more than just linking pieces and stock. Let's take a closer look inside. Every material group has a name, and it can belong to one of two types, 2D or 1D. Each material group is assigned a cutting device, which we'll show later, and comes with specific parameters. For 2D materials, we define properties such as thickness, surplus, margin, formatting width, and cut dimensions. We can also set options for the pieces and stock belonging to the group. First, there's structure, a surface pattern that runs along either the length or width. Pieces without structure can be oriented freely, but if the material has a pattern, the orientation of the pieces must match the structure of the stock. Here we can specify whether the material can be veneered. Next, we define whether the material can have different colors. Keep in mind that these colors don't refer to the material itself, but whether it can be painted after cutting. This doesn't affect the optimization process. It's purely for production purposes. We also decide whether the surplus and margin can be changed. If not, we define them here in the material group. Otherwise, we set default values. Surplus increases the piece size by adding extra space to each edge. For example, entering 2 here adds 4 mm to both the length and width, 2 mm on each side. Margin works the opposite way, decreasing the piece size. If we enter 2 here, the length and width of the piece will shrink by 4 mm, 2 mm on each side, left, right, top, and bottom. Next, we have a default formatting width for stock items. This is useful when the stock from your supplier has imperfections like broken, scratched, or rough edges. You can't cut pieces directly from such stock, so you need to format it first. If this material group always requires formatting, enter a default formatting width here, say 10 mm. When new stock items are added, this formatting value will automatically apply to all edges. Finally, for veneered materials, you can choose to cut using either net or gross dimensions. Net dimensions don't include veneer thickness, while gross dimensions account for it. As you can see, the piece dimensions used for cutting might differ from the originally entered values due to surplus, margin, and whether you're using net or gross dimensions. So, make sure you fully understand how this works before sending cutting layouts to production. Now, let's talk about kerf. The kerf is the thickness of the material wasted by the cutting device. For example, when you're cutting wood with a saw blade, the blade itself has some thickness, and as it cuts, it leaves behind a line of empty space. That's the kerf. This setting tells the optimizer how much waste is generated by the cutting device. In addition to kerf, we have an option that allows the optimizer to generate waste narrower than the kerf. This assumes you can remove it easily using the saw blade or another method. It's typically used for materials like wood or furniture boards. This option helps reduce waste and provides better optimization results. Next is the stack cutting feature. This is an experimental option that allows you to cut multiple stock items simultaneously using the same cutting schema. The stack size is set here by default, but it can also be changed in the stock options, so you can define different stack sizes for the same material group. We'll keep this option enabled for demonstration purposes. Moving on, we have the recycle criteria, which include minimum and preferred dimensions. Minimum dimensions indicate the smallest size that can be considered reusable, while preferred dimensions specify the target size for reusable waste. The final setting here is for reusable waste formatting. If reusable waste is generated, you can set a formatting value to be automatically applied to it. Lastly, we have the standard size list. This tells the optimizer which sizes in stock are considered standard. Standard stock items are easily reorderable from suppliers, and the optimizer will treat them differently. This includes distinguishing between standard sizes and reusable waste, and allowing additional standard materials to be used as viable stock. If you haven't seen it yet, this was covered in a previous video, so be sure to check that out. Now, let's return to the stock settings, where you'll notice a new option, stack size. This allows you to define how many items you want to optimize in a stack. For example, you could set 5 items per stack and then specify how many stacks you have available. The total quantity is calculated by multiplying the number of stacks by the stack size. For instance, 10 stacks with 5 items per stack result in 50 items in stock. You'll also see that the default formatting width has been applied to the edges of the stock items. This can be adjusted at any time for each edge individually. Let's take a look at the piece settings briefly. Here, with the color option enabled, we can specify color as well as surplus and margin. For example, we could increase the surplus to 2. Typically, you don't want both surplus and margin to be editable simultaneously, as they may conflict. So ensure only the settings meant to be adjustable are enabled in the material group settings. We'll cover veneering in more detail in another video, so I won't go into it here. That wraps up our discussion on 2D material groups. We'll explore 1D material groups in the next video. Thanks for watching, and see you next time.